So this sample problem is for the ideal gas law. I can tell it's ideal gas law, other than the fact that it says it, because the problem involves moles. All ideal gas law problems involve moles. Now, the question reads, what volume is occupied by 0.250 moles of carbon dioxide gas at 25 degrees Celsius and 371 torr? Using my chemistry reference sheet, I see the ideal gas law is PV equals nRT. So I list out each variable, P, V, N, R, and T. P is for pressure, so that's the 371 torr. V is for volume, and that's our unknown. N is the amount, so that's 0.250 moles. R is the universal gas constant, which, according to my sheet, is 0.0821 liters times atmospheres over mole kelvins. So 0.0821 liter atmospheres per mole kelvins. And then temperature is 25 degrees Celsius. Now, the trick with the ideal gas law problems is that they need to be all having the correct units. The units must match those of the universal gas constant. Volume must be in liters. Pressure must be in atmospheres. Amount must be in moles. And temperature must be in kelvins. Now, pressure is in torr. That needs to be in atmospheres. So we have to convert it. Now, the pressure conversions say that 1 atmosphere is equal to 760 torr. Since I'm starting with torr, I draw a small grid. I put the 760 torr on the bottom, and the 1 atmosphere goes on top. 371 divided by 760 equals 488 atmospheres. 3 significant figures, 3 significant figures. Now, temperature must also be in kelvins. So I do that by adding the 273, and I get 298 Kelvin. Now, the formula once again is PV equals nRT. I have to isolate the unknown of V while it's still in letter form. To isolate it, it needs to be all by itself on the same side of the equation and a numerator. Now, V is already a numerator, but it's being multiplied by P. So I want to do the opposite of multiplication, which is division. That way the P's cancel out, leaving V all by itself. But of course, what I do to one side, I have to do to the other to maintain balance. So volume is equal to N times R times T divided by P. So, plugging in the correct numbers, N is 0.250 moles. R is 0.0821 liter atmospheres over mole kelvins. And T is 298 Kelvin. 298 Kelvin. All divided by P, the pressure, which once again is 0.488 atmospheres. Now, when I do my calculations using my calculator, if the number's on top, I multiply. If it's on the bottom, I divide. So, I go 0.250 times 0.0821 times 298 divided by 0.488 equals. I look to all of my measurements to see which has the fewest number of significant figures, and that's how many I must round my answer off into having. I don't look at R because it's a constant, not a measurement. So I ignore that for significant figures. But since everything else has 3 significant figures, I round my answer off into having three significant figures as well. So I get 12.5. As far as units, it's volume, so it's going to be liters. And the way I can tell is because moles cancel out, kelvins cancel out, atmospheres cancel out. The only thing that doesn't, liters, makes that the correct units. And now I'm done.